Okay, so we all want to build smarter AI, right? AI that can actually understand our company's most important documents. But there's this huge wall that always seems to get in the way. These dense, messy PDFs that lock up all that crucial knowledge. Well, in this explainer, we're going to dive into a brand new superpower that is changing all of that.
I mean, seriously, why is it so hard for our super advanced AI to read a document that you and I can scan pretty easily? It's a frustration that pretty much every developer building AI apps has felt. You know you have this goldmine of information locked away in financial reports, legal contracts, or technical manuals, but getting an AI to make any sense of it feels like a nightmare.
And that right there brings us to the heart of the problem, what I like to call the document dilemma. You see, the single biggest bottleneck in building powerful, document-savvy AI today, it's not the model. Nope, it's the prep work. It's that painful, super time-consuming process of trying to turn unstructured chaos into structured intelligence.
Now, what we're all really trying to do here is something called retrieval augmented generation, or just RAG for short. The idea is actually pretty simple. We want our AI to look up information in our own documents before it answers a question. This makes the answers factual, totally up to date, and, this is the big one, it grounds the AI in reality, which massively cuts down on those wild AI hallucinations.
But here's where things fall apart. On the last, that's the dream, right? Smart, factual AI grounded in your own data. But the reality of getting there is, well, it's on the right. It means wrestling with these ridiculously complex Python scripts and a bunch of external libraries. You're fighting with misaligned columns and tables. And oh my gosh, don't even get me started on merged cells. They just break everything. This whole messy prep stage is where so many amazing AI projects just grind to a halt.
But what if that entire messy, frustrating reality could just disappear? That's what we're looking at next. Google has just rolled out a new superpower that brings its advanced document AI tech right into BigQuery. And trust me, it is a complete game changer.
No, really, just stop and think about that for a second. What if all that complicated parsing, all that structuring and prep work could be done with a language that every data professional already uses every single day? What if you could just do it all with SQL?
And that is exactly what this new function, ml.processDocument, lets you do. It's now generally available in BigQuery, and it is the hero of our story. It lets you call on Google's super powerful document AI processors to parse and intelligently chunk your complex documents right there inside your database with just a simple SQL query. It's incredible.
So, what does this new superpower actually get you? Well, for starters, it's got a Gemini-based parser that truly understands document structure. You also get the scalability and simplicity of SQL. But the real secret sauce, the most critical part, is what's called layout-aware chunking. This means it's smart enough to break documents into meaningful pieces, which is the absolute key to building a high-quality RAG pipeline.
Okay, this all sounds amazing in theory, but how does it actually work? Let's walk through the 5 steps to building a complete RAG pipeline, turning that document chaos into AI genius, and doing it all inside BigQuery.
So here's the whole process, soup to nuts. You create a parser, use it to make your chunks, turn those chunks into vector embeddings, index them so you can search them fast, and finally, retrieve the right info to generate an answer. It looks really straightforward, and that's because, with this new function, it finally is.
All right, so steps 1 and 2 are where the new magic really kicks in. First, you set up a layout parser over in the Document AI interface. Then, from BigQuery, you just point the ml.processDocument function at your PDFs. That's it. Seriously? Document AI does all the heavy lifting, analyzing the layout, and giving you back these perfectly structured, context-aware chunks of information.
Now, for steps 3 and 4, we've got to make those chunks searchable by meaning, not just by keywords. So we use another BigQuery ML function, ml.generate_embedding, to turn each chunk of text into a string of numbers. That's a vector. Then we create a vector index, which is kind of like building a super fast GPS for your data that can find the most relevant information in a flash.
And the final step brings it all home. When a user asks a question, you use vector search to instantly find the most relevant chunks from your documents. You then package up that context along with the original question and hand it to a large language model like Gemini using the ml.generateText function. And what do you get? A concise, accurate answer, totally grounded in your own data.
So let's see this thing in action. The team put this exact pipeline to the test on a notoriously complex document, just to see how smart the answers could really get.
So the challenge document was the Federal Reserve's Survey of Consumer Finances, and let me tell you, this thing is a beast. We're talking nearly 60 pages of dense text, incredibly detailed tables, charts. It's exactly the kind of document that would give simpler parsing methods a complete meltdown.
So after running the pipeline, they asked a pretty complex question about how net worth changed over 2 different time periods. And just look at this answer. It's perfect. It's concise, it's accurate, and it pulls together information from multiple different places in the document. This is the wow moment right here.
So how in the world did the AI do it? This is what's so cool. To generate that one single sentence, the RAG system found and used 3 different chunks: a line of text from page 1, a specific value from a big table on page 12, and the critical context from a tiny footnote all the way on page 15. And this is just the perfect example of why that layout-aware chunking is such a big deal. The AI could only construct that high-quality answer because ML.ProcessDocument understood that a cell in a table and a footnote were separate, meaningful pieces of information. It didn't just see a flat wall of text, it saw the structure of the knowledge.
Okay, so let's zoom out. Why does one new SQL function matter so much? Because the future of enterprise AI isn't just about building bigger models. It's about having better data. It's about structuring the unstructured. At the end of the day, this integration delivers on 3 huge promises. Simplicity, you can do it all with SQL, a skill your data teams already have. Scalability, you can process documents at a massive scale, right where your data already lives. And power, it unlocks a much higher quality of AI answers, all because the underlying data is structured so much better from the start.
And when we talk about scalability, we are not kidding around. The system can now handle documents up to 100 pages long, and it processes them faster than before. This is absolutely enterprise-ready.
So here's the bottom line. What used to be the biggest, messiest, most frustrating bottleneck for building enterprise AI is now a clean, scalable, and native SQL operation right inside your data warehouse. That barrier to entry, it just got lowered, big time.
Which really just leaves us with one final, important question to think about. With this new superpower, now literally at your fingertips, what incredible knowledge that's currently locked away in your company's most complex documents are you finally ready to unleash?